is large-scale object recognition with weak supervision. So I'm from the Chinese Academy of Science. Okay, so we are in this competition. The task to be classification and localization with additional training data, and ordered by the classification error we run at first. So here we only use the classification data, and the localization result is returned by using the full image as object location. So here is the outline of our report: motivation, method, and results. So here is the motivation. So the basic idea of our method is to use the weakly supervised learning to improve classification. Okay, so why weakly supervised learning? Knowing where to look, recognize the object will be much easier. Oh, sorry about that. Will be much easier. But in the classification only task, no annotations or the location are available. So how to deal with that? Okay, so here the method is to use a bunch of images and to learn a detector from these images and apply on the image again. So what this task is called, this is called the weakly supervised localization. Okay, so here is the summary of some recent results on the Pascal VOC 2007 dataset. And we can see that the highest one is about 33, which is given by the DPN, which is a fully supervised learning method, and some others are the weakly supervised method. We can see that the results increase all the way. And here are some list of the papers. Maybe it takes you some time to see that. And we list two behind. One is this one, 26, which is one of our paper, one of our work which has been submitted to the Team Army. And the other, the 31, 6, is the weakly supervised observation with latent category learning, published in ECCV 2014. And if you want to look at this paper, you can find it here. The poster session 4A, number 34. Okay, so here are our work. So the two studies of the work actually obtained promising results on the object location dataset. So here we have a 31, we have a 26, but for the consideration of high efficiency in large-scale tasks, we use the second one. So this one is actually faster. So what is the method? So this is our whole framework. So we have four steps. The first one is the CNN classification. The next one, weakly supervised localization. The third one is we restore the detection prediction. And the fourth one is we combine the score of the classification and detection to finally improve the classification performance. Okay, so we will look each step one by one. The first one, we use a very shallow CNN architecture, which is the same to the CNNS published in this paper. So, okay, this is very simple. We will not talk about that. Okay, the second one in our framework is the multiple instance linear SVM. So this is a whole framework which actually contains several parts. The first one is images and region proposal, representation, and multilinear mining. Okay, the first three steps are very similar to the RCN, but actually this method is weakly supervised learning. So let's look at these three steps. The first one, we have the region proposals. So actually there are a lot of region proposals we can use in recent days. So what is a good proposal algorithm? I think it should have a high recall and overlap with the ground truth, and also with a small number because we want to have a low computational cost. Actually, in our work, we use the MCG pre-trained on the Pascal VOC 2012. So this is why we use the additional data. We pre-train the proposal on this dataset. Okay, so in the training, we use 128 windows per image, and in testing, we use 256. So compared to the selective search, we had our performance, our efficiency can be improved much more. Okay, so after generating the regions, the next step is to represent them. So how do we, what is the region representation we use here is of course the standard representation. So actually, in computer vision, there are a lot of feature representation you can use, such as some low-level features and mid-level features, and recent several years the CNN. Okay, this is all the same to the RCN. Okay, and the third step is to find the positive windows. What we call here is the positive window mining. So actually there are a lot of works on this method. We can see that there are clustering, topic models, CRF, and the most typical one is the multi-instance learning. So here there are a lot of methods in the multiple instance learning. We use the SVM. So here is the objective function and organization of our method. Here I won't talk about in detail. So just pay attention here. This is a linear model, so it can be very fast. So and we use the trust region to optimize. So here is the comparison of the different optimization algorithms to optimize our object function. We can see that the green line is actually our method, and some of others is also our method, but using different optimization algorithms. We can see that the trust region can converge very fast. Okay, the third step is after we use the weekly supervised learning, we're gonna rescore this. So why do we have to rescore? So let's look at the score output from the detection phase. We have 128 points per image, and we have 1,000 class. So we just do max pooling under this direction. So we got 1,000 dimensionality the score, right? So why we use the softmax to rescore? Because no, not this one. So because we observed that in a lot of images, okay, the score, you can see the purple one and the red one, they are very similar, right? So in this case, assume the ground truth is the purple one. So we want to surprise the red one, and we want to enlarge the purple one. So this is the case. A lot of similar object category will give the similar response. So we want to surprise the response. So this is why we use the softmax. Because softmax can consider all the categories simultaneously at each mini batch of the optimization. This is why we use the softmax. We can see that after we use the softmax, the response on the right one is much smaller. The fourth one is after we do the rescore. So next step is to combine the score of the detection and the classification. So here, how do we combine it? We use a very simple method, the linear combination. So the scores of the classification and the scores of the weakly supervised localization. So here maybe you will ask why we don't use any other algorithms. I think there are a lot of better algorithms such as context VM and a lot of these methods. So why don't we use this? Because actually, the funny thing is we have tried all these other strategies of score combination, but none of them works. So for now, I still don't understand it. Maybe I didn't operate this correctly. So maybe you can discuss later. Okay, so finally the results. So here we talk about the classification without the weakly supervised localization. We use the very shallow framework. So here are our results. The baseline with only one CNN is 13.7. And actually we have trained 4 CNNs. The average is about 12.5. 1% improvement. Okay, so let's look at the weekly supervised learning on the ImageNet 2014. So this is a localization, this is a detection error. So we can see that the baseline, if we use the full image of our object location, we get a detection rate of 32. And if you use the weekly supervised learning, the multi-instance linear, we get 31, right? So the winner is 25. I think our results are not that bad, right? It seems okay. So here are some of the weekly supervised localization results. You can see the first one is a cat and the second one is a dog. It can localize very accurate, I think. So this one, I forgot what is this thing is. Maybe you can guess. Sorry, I forgot that. Okay, so let's look at the results on the Pascal 2007. And this you have seen before at the beginning. And this is the results. Okay. Also, we have done some results on some experiments on the last year's detection challenge. So this is the results of the first 100 categories, and this one second. So the red one is our results, and the blue one is the fully supervised DPM result. So actually, in this task, our results obtained 9.6 in average precision, and the DPM only 9. So we beat DPM. But consider we only use the weakly supervised learning, and we don't use the label of object location in training data set, which I think is actually amazing result. Okay, so here, so we have seen the power of this weakly supervised learning. So will it be effective on the classification? So we use our weakly supervised learning for the classification, and we see what happened. So here, the result is, I think it's not that good, right? It's only 70 in the top 5 arrow. And we observe some images that we can see that the images, the object location actually it can be detected accurately, some of them. Maybe this object, so it will demonstrate the assumption I have talked in the beginning. So knowing where the object, recognize objects will be much easier. It's not that easy, right? So next, the third step, the third result is our rescoring result. We use the softmax. So here, another, I list all the results here. The baseline is one thing that one average 12.5, and directly weakly supervised learning 17. And if you use a rescore on this weakly supervised localization, we got almost a 4% improvement, which I think is a very large improvement. Okay, so the final things, the softmax-based algorithm successfully surprised the predictions of other appearance-similar object categories. So this is why it can work. So the final is we combine the score of the classification and detection, which is a very simple linear combination. So here we combine these two, 12.5 and 13.5, and we finally get 11.5. So the improvement over the classification, I think, is 1%. Right? So here, I think the weakly supervised localization and classification can be complementary to each other. So this is our final results. The location is here. So this table is obtained by this paper. Okay, finally, we have two conclusions. The first, I think, the weakly supervised localization always helps classification. I think you can maybe further improve the Google Nets, maybe. The second one is, the weakly supervised localization has large potential because this kind of data is very cheap to get. You don't have to label all the locations manually, right? So I think maybe it has large potential in the future. So thank you.